Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up until now, we've only been dealing with simple functions, but we know and have seen functions that are nested inside one another, or better known as composite functions. In this video, we're going to introduce arguably one of the most important rules in differentiation, known as the chain rule. Before we dive in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So the chain rule says that if we want to differentiate a composite function, f of g of x. So notice how g of x here is our inside function, and then f is our outside function. So if we want to differentiate this, this is going to be f prime of g of x multiplied by g prime of x. So in other words, the secret here is to differentiate the outside and leave the inside function alone. Then we multiply by the derivative of the inside function. So it's important that you're able to figure out what the inside function is and what the outside function is before you start differentiating. So let's take a look at what we mean by that through a couple of examples. We want to differentiate these four functions here. So notice that for part A, you're welcome to actually distribute x squared plus 1 to the power of 5, but that is going to take forever. So we're going to use chain rule here to make our life a little simpler. Now the inside function here is x squared plus 1, and then the outside function is that to the power of 5. So this means, according to chain rule, f prime of x is going to be, we differentiate the outside function first, so using the power law, that is going to be 5 times, and then we leave our inside function alone, which means we copy it down, which is x squared plus 1, and this is now going to be to the power of 4. Next, we're going to need to multiply this by the derivative of the inside function. And the derivative of x squared plus 1 is equal to 2x. So therefore, f prime of x here is going to be 10x times x squared plus 1 to the power of 4. For part B, our inside function here is 3x, and the outside function is sine. So this means y prime is going to be equal to the derivative of sine, which is cosine, and it's going to be cosine of the inside function, which is 3x, and then we multiply this by the derivative of the inside function. So derivative of 3x is just 3, which means y prime is equal to 3 cos 3x. For part C, our inside function is x squared, and our outside function is the natural log. So therefore, d by dx of ln of x squared is going to be equal to, the derivative of a natural log is 1 over the argument, and the argument here is x squared. Then we're going to multiply this by the derivative of the inside function. So the derivative of x squared is 2x. So therefore, this is equal to 2 over x. And then finally, the last one, our inside function is 5x, and then the outside function is our exponential function. So therefore, y prime is equal to, now the derivative of e to the x is just e to the x. So therefore, this is going to be e to the 5x, and then we multiply it by the derivative of 5x, which is just 5. So y prime is equal to 5 times e to the 5x. So working with chain rule is almost like peeling an onion. You work your way from outside inwards. Now these four examples here all only have 2 layers. We have our outside function and we have our inside function. Let's take a look at the next example where we have a couple more layers. So here we have sine squared of e to the power of 3x. The idea here is the same. We keep peeling the outside and work our way in while keeping the inside the same. So here we actually have 4 layers. So to see what I mean, let's go ahead and rewrite this. So f of x is equal to, so sine squared is really just sine of e to the power of 3x, and then it's this entire thing squared. So now we can see that our outsidemost layer is squared. The next layer in is our sine. And then the next layer in is the exponential function e. And finally, the insidemost layer is 3x. So let's go ahead and work our way in. Now, chain rule says we're going to take the derivative of the outsidemost function, so something squared. And using the power law, something squared is going to be 2 times that something to the power of 1. And the something in this case is everything that's inside the square bracket, which is sine of e to the 3x. And now we need to multiply this by the derivative of that inside function. So the inside function right now is everything inside. So that means we want to take the derivative of sine of e to the 3x. And to take the derivative of sine of e to the 3x, we have to apply chain rule again. So this time, our outsidemost function is sine. So therefore, this is equal to, so copy everything down, that's 2 times sine of e to the 3x multiplied by the derivative of sine of e to the 3x is going to be cosine of, now the inside function of sine of e to the 3x is e to the 3x. And now we need to multiply this by the derivative of e to the 3x. And this time, to take the derivative of e to the 3x, our outside function is e, which means this is equal to 2 sine e to the 3x times cosine of e to the 3x times, and the derivative of e to the 3x is going to be e to the 3x times the derivative of 3x. So finally, this is now our last step. So that'll be 2 times sine of e to the 3x times cosine of e to the 3x multiplied by e to the 3x. And then the derivative of 3x is just 3. So that means we have times 3. So therefore, our final answer here is going to be 6 times sine of e to the 3x cosine e to the 3x times e to the 3x. And now let's do a quick recap of what we covered in this video. We learned that the derivative of a composite function f of g of x is the derivative of the outside function with the inside function as its argument, and then we multiply it by the derivative of the inside function. And the trick with chain rule is to always work from the outermost layer inward. We never change the inside while we're differentiating the outside. And if a function has 3 or 4 layers, we simply continue the chain of multiplication until we reach the innermost variable, hence the name chain rule. So the most important thing is to be able to identify what is the outermost function as we work our way inward. And now it is your turn to give this a try. Can you find the derivative of this composite function on the screen here? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.